A type of object in Mathematica that you really want to get used to is what I call a list of lists. So for example, let me make one of these lists of lists. Let me call it M. And I'm just going to randomly choose some things to go into it. The first thing in it is going to be the list 1, 3. The second thing in it is going to be the number 7. The third thing in it is going to be the list 2, 4, 6, 8. And the last thing in it is going to be a list with the string high and then the number 4 in it. So there's M. If I had wanted it not to get printed to the screen, I could have put a semicolon after it, like this. Both define M the same way. And so say I do, what's the length of M? What do you think that's going to be? It's going to be 4. This is the first thing, this is the second thing, this is the third thing, this is the fourth thing in it. So for example, if I want to get the third entry in M, how do I do that? Remember to use two square brackets, not just one. Okay, the third thing is this list here. So that's why I call it a list of lists, because one of the things in my list M is this other list, 2, 4, 6, 8. And what if I want to get the second entry in this list of lists? I could do square bracket 2, then closing off the square brackets. And so where did this come from? First, the 3 got me to here, and then the 2 got me to this number 4. If I try to do it again, like say I try to do bracket 1, then it says 4 doesn't have a part 1. What are you talking about? So I can only go as deep as the list of lists goes. You might wonder why we would care about lists of lists. Well, one reason why we care about them is that when we make a matrix, we're going to make it as a list of lists. So for example, let me call this matrix. And I know there's no chance I'm overwriting something that's already defined in Mathematica because I used a lowercase m. Let me do the matrix 1, 2, 3, 4, and then 5, 6, 7, 8. So in general, we know the lists of lists. The inside lists don't have to all be the same length. Like here was one of length 2, here was one of length 4. But if you're making a matrix, then how should you think of it? You should think of each inside list as one of the rows in the matrix. So how can I make it look more like a matrix? Let me type in matrix, and then let me do / matrix form with both of those words capitalized. Okay, now it looks more like a matrix. The other version of this that is sometimes useful is if I do matrix and then table form. So here it's not so obvious why that's better, but let me show you M. If I do matrix form, okay, it looks kind of strange, but if I do table form, it's going to look more normal. So it's like there's a table, and the first inside list was the first row, second inside list was the second row, and so on. What if I want to get the length of each inside list in M? How can I do that? Well, I could do something like table, length of x, and then I'm going to use that second type of iterator for every x in M. If you want, you could name this x more directly. You could call x something like inside list. And so the number 7, I didn't put it in a list, so that's why it says the length of the second one is 0. If I changed it a little bit, say instead of making it the number 7, say I made it, it's going to look very similar, say I made it the list that contains only the number 7, and I evaluate it. Now let's go back here and look at this table. Now that second entry went up to 1, because now instead of being the number 7, here we can look at it, instead of being the number 7, it was the list that just has 7 in it. Okay, so that's a subtle difference between the number 7 and the number 7 inside curly braces. Say I want to make a matrix that looks like 1, 2 up to 10 in the first row, 11, 12 up to 20 in the second row, all the way up to 51, 52, up to 60 in the, I guess it's the 6th row. How could I do that? One way to do it is to make a list of lists using table. And there's definitely more than one way to do this. Here, let me call this, how about new matrix? And so what does table make? Table makes a list, and I want the first entry in my list to be 1, 2, up to 10. I want the second entry in my list to be 11, 12, up to 20. So the things inside my table, the expressions inside my table, those are also supposed to be lists. And I have some choices for how to do it. Let's say I want to go for I from 0 up to 5. The default step size is 1. And then I want to go 1, 2 up to 10 for 0. I want to go 11, 12 up to 20 for 1, and so on. How can I do that? Well, I can say 10 times I plus j. And now I want for j from 1 to 10. So you should both be able to write these yourself, and also, maybe more importantly, you should be able to look at one of these that I've written. You'll probably have to look at it pretty slowly. I have to look at it slowly and figure out what's the list of lists that this is going to make. Okay, so let's look at it. I've saved it. I put a semicolon so nothing got printed to the screen. And now let's look at it in matrix form. Hey, there we go. That's exactly what I wanted. What if I want a table that looks like 1 in the first row, 1, 2 in the second row, 1, 2, 3 in the third row, all the way up to 1 up to 10 in the 10th row? How could I do that? Well, again, it's going to be a list of lists. Let me call it new table. And let me say this is table, table, and then let's say this will be I. I'll go in a different order this time. For I from 1 to j, and the j is the thing that's increasing in each of the rows. So j, I'll go that from 1 to 10. Okay, it doesn't look very good right now, but let's put it in table form. Okay, there we go. That's exactly what I wanted.